Welcome back to Generative AI 101, the podcast where we turn the cryptic world of AI into something as palatable as your favorite comfort food. I'm Emily Laird, your guide through this digital adventure. Today we're continuing our mini-series on Transformers with the mechanics of Transformers. Not the explosion-prone Michael Bay variety, but the sophisticated models that are reshaping our digital world. Ready to geek out? Let's get started. Welcome to Generative AI 101. All right, let's peel back the layers and see what's behind these transformers. We're talking about the nitty-gritty details that make them rock stars of the AI world. Think of this episode as your backstage pass to understanding transformer mechanics. First up, the self-attention mechanism. Imagine you're at a party trying to follow multiple conversations at once. Self-attention is like having superhuman hearing, allowing you to focus on each conversation individually and understand how they all relate to each other. Here's how it works. Each word in a sentence is transformed into three vectors: query, key, and value. The query asks questions. The key provides context. And the value carries the actual information. These vectors interact to produce attention scores, which determine how much focus each word should receive. Think of query, key, and value vectors as a search engine. The query is your search term. The key is the index of all available documents. And the value? The actual content of the documents. The query finds relevant keys, which then retrieve the corresponding values. This process ensures that each word in the sentence gets the attention it deserves, based on its relevance to the others. Then there's the visualization of attention maps. So attention maps are like heat maps at a party, showing where all the interesting conversations are happening. They help visualize which words are focusing on which others, providing insight into how the model understands relationships within the data. Next, let's talk about multi-head attention. So if self-attention is like having superhuman hearing, multi-head attention is like having multiple sets of superhuman ears, each tuned to different conversations. Multi-head attention involves splitting the query, key, and value vectors into smaller parts and processing them through multiple attention heads simultaneously. Each head focuses on different aspects of the input, capturing various relationships and nuances. Single head attention is like having one set of superhuman ears. It's impressive, but it can only handle so much. Multi-head attention allows the model to consider multiple perspectives at once, making it better at understanding complex data. So, what are some examples of multi-head attention in action? So, in language translation, one head might focus on word order, another on verb conjugations, and another on idiomatic expressions. Together, they provide a richer, more accurate translation. It's like having a team of expert translators working in harmony. Now let's get into the nitty-gritty of training these behemoths. Training a transformer is like preparing for a marathon. It requires stamina, strategy, and a whole lot of patience. Transformers are trained on vast amounts of data using powerful GPUs or graphic processing units and TPUs or tensor processing units. If you're not familiar with these, they essentially speed up and support AI training. Techniques used in training these models include gradient descent and backpropagation, which helps the model learn by minimizing errors over time. It's like running laps and adjusting your stride with each lap to improve your time. Now, training transformers is computationally expensive and requires massive data sets. And I mean massive. It's like training for an ultra marathon while eating a mountain of spaghetti. You need the fuel, but it's a lot to handle. Overfitting, underfitting, and data sparsity are just a few hurdles to overcome. So there you have it, an inside look into the mechanics of transformers, from self-attention and multi-head attention to the grueling training process. We've covered the essentials that make these models the titan of the AI world. And I want to add, as I add to my students or industry professionals that I partner with, or industry leaders that I get the pleasure of speaking with, collaborating, and consulting for, when we type an input prompt into a large language model, and we'll get into this, we will instantly receive an output. We're so used to this input-output instant gratification. The reality is, there's a lot going on under the hood of these large language models. So putting in an input and receiving an instant output is truly an impressive feat of science, technology, engineering, and beyond. That's all for today's deep dive into transformer mechanics. In the next episode, we're going to focus on how transformers process text. And in the episode after that, we're going to talk about how transformers generate text. If you got questions, thoughts, or just want to connect, find me on LinkedIn. Emily Laird, Laird. Let's keep the conversation going. Until next time, stay curious, stay adventurous, and remember, you know more about transformer mechanics now than you did when you arrived.